All right, welcome. Today, we're going to move way beyond the basic select star from. We're diving into the powerful SQL objects that can transform your simple queries into genuinely smart, scalable, and secure data systems. This is where you stop just writing queries and start building real architecture.
I mean, really think about it. Sure, you can write some killer, complex queries, but are you building systems that are efficient, secure, and, maybe most importantly, easy for everyone else on your team to actually use? Well, that's the challenge we're going to tackle today.
Okay, let's use an analogy. Picture a single, giant notebook that holds all of a school's data. Now, students, they just need to see their grades. Teachers need to see their class summaries. And the school administrators, they need to see everything. So what are you going to do? Hand copy a brand new custom notebook for every single person, every single time they ask? No way! That would be a total nightmare to manage.
And that is exactly where SQL's secret toolbox comes into play. These advanced objects are what let SQL grow from just a simple query language into this powerful framework for building really robust and reliable data systems.
At the end of the day, why do we even need this stuff? Well, it's pretty simple. We use these tools to hide away complexity, to get a major boost in performance, to lock down our data, and to stop writing the same chunk of code over and over again. This is really how you make that jump from being a query writer to becoming a system designer.
All right, let's dive in and start with the first and probably most common tool in our toolbox, views. You can just think of them as the ultimate smart shortcut for your database.
You know, at its core, a view is actually a really simple idea. You take a complex query, the one with all the joins and weird business logic, you give it a name, and that's it. From now on, you can just query it like it's a simple table. And here's the absolute key. It stores the query itself, not the data that comes from the query. Yeah, this slide nails it. A view is not a separate copy of the data. It's more like a live window that's looking directly at the original tables. So if the data in those original tables changes, what you see through that window changes right along with it. Instantly. It's always live.
Okay, but why is this so useful? This is where it gets really good. You know that monster query you wrote? The one that's 100 lines long with 5 different joins? Well, you can wrap that up in a view called monthly_sales_summary, and suddenly your entire team can just write select asterisk from monthly_sales summary. It's way simpler, it's consistent, and you can even use it to hide sensitive columns from certain users, which is a huge win for security.
Okay, but hold on. Here's a super important professional truth you gotta know. Just because a view makes your code look simpler, it doesn't mean it makes the underlying query run any faster. The database still has to do all that heavy lifting every single time you query the view. And that little fact leads us perfectly into our next tool. So, to solve that exact performance problem, we have to talk about materialized views. If a regular view is a shortcut, you can think of this as our accelerator. I mean, this is the exact scenario, right? You've built this beautiful, simple view for your dashboard, but every time someone opens it, it takes 2 minutes to load because that underlying query is an absolute beast. Yeah, that's just not going to work.
So, what's the solution? It's a materialized view, and the magic word here is stores. Unlike a regular view that just saves the query's definition, a materialized view actually runs the query and then physically saves the results to disk, creating what is essentially a real table.
Right, so if a regular view is like a live window, a materialized view is like taking a photograph of that window. It's a snapshot of the data at one specific moment in time. And as you can imagine, looking at a photo is always going to be way faster than trying to recreate the whole scene from scratch every single time. That's the performance boost. Okay, this slide is super important, so let's really break this down. A regular view is virtual. It's just a window. A materialized view is physical. It's a photo. Now for freshness, a regular view is always live. A materialized view, it's a snapshot, so it gets stale, and you have to remember to refresh it. And that brings us to the fundamental trade-off. A regular view can be slow, but it's always fresh, while a materialized view is incredibly fast, but its data is only as current as its very last refresh.
This right here, this is one of those professional rules you just have to burn into your brain. You're dealing with the triangle of freshness, speed, and complexity. If you want blazing speed and perfectly fresh data, your refresh process is going to be super complex. If you want speed and a simple process, you have to be okay with your data being a little stale. You can't have it all. Pick two.
All right, let's totally switch gears for a second. We've been talking about how we can optimize reading data, but what about when we're creating it? How do we reliably generate unique IDs for all our new records? And for that job, we turn to the sequence.
A sequence is basically a number dispensing machine for your database. It's a standalone object, totally separate from any table, and its one and only job is to hand out the next number in line, 1, 2, 3, 4, and it guarantees you'll never get the same number twice.
Now, a lot of you are probably thinking, hey, isn't that just like an auto increment column? And that's a great question. The key difference is that auto increment is stuck. It's tied to one single table. A sequence is independent, and that is a total game changer. Imagine you need one universal ID for an audit log that tracks changes across your users table, your products table, and your orders table. Auto increment can't handle that, but a single sequence can. It becomes one source of truth for IDs across your entire system.
And here is a massive truth bomb for you. A sequence guarantees that every number it gives you is unique. What it does not guarantee is that there won't be gaps in the numbers. If a transaction fails and gets rolled back, or if a server reboots, some numbers can get skipped and they are gone forever. So what's the takeaway? Please, whatever you do, never use a sequence number for something a customer will see, like an invoice number. They're for internal IDs, period.
Okay, so we've covered a lot. We've got views for making things simple, materialized views for making them fast, and sequences for giving them unique IDs. So now let's pull all this together and really start thinking like a data architect. And this is basically your cheat sheet, your practical go-to guide. When you're facing a problem, just come back to this. If you need to simplify that gnarly join for your team, you use a view. If you need to speed up a slow dashboard, use a materialized view. Need unique IDs that work across multiple tables? That's a job for a sequence. It's all about picking the right tool for the job.
Look, knowing the right tool is great, but knowing the common mistakes, that's what separates the pros from the amateurs. So let's just hammer these home. First, do not use a view and just expect it to be faster. It won't be. Second, if you use a materialized view, you absolutely must have a plan to refresh it. And finally, please don't assume your sequence numbers will be perfectly consecutive, and definitely don't show them to your customers.
So I really want to leave you with this one last thought, because I think it just wraps everything up so perfectly. Your tables, they just store the raw data. It's these advanced objects, the views, the materialized views, and the sequences that let you build an actual architecture around that data. They make it understandable, fast, identifiable, and in the end, safe and incredibly powerful.